Hello again. So now we're moving on to chapter 18, or I like to call it chapter 4 part 2 because it really goes into a lot of different parts of the biochemistry chapter. Actually, now I think about it, I think it's chapter 2. So anyway, this is where we dive deeper into some of the biochemistry, especially after talking about the digestive system, because this kind of goes hand in hand with how a lot of this works. So, as I was mentioning last time, we were talking about what happened to the digestive system, what it is doing, and is breaking down everything that we ingest into its monomers, so that what it comes from. So that way then we can take it and rebuild it back up into us. And for better or for worse, when I eat cake and gain a few pounds. But it's just so yummy. Anyway, so that's kind of what I talk about, why I call it like Return of Chapter 2 or Chapter 2, Round 2, Electric Boogaloo. So anyway, so now that we know how the whole digestive system works, let's see where it goes, let's see where what we eat goes and why we need it. So again, food intake, what we're doing is we're breaking this down so we can get those monomers so we can turn it back into things. So again, we break it down into proteins. We break it down into complex carbohydrates. We turn it down into triglycerides. So again, we kind of know this one because we've talked about it on and off. So again, what happens, we eat it, the complex carbohydrates, glycogen gets stored in the liver and the skeletal muscles so we have enough energy to walk around and occasionally if there's an emergency, run away from angry dinosaurs or zombies, whatever. And, again, we break it down into glucose, and then we send that glucose into energy production to make ATP, so that way we can run our cells. That's the main one, a lot of us think of. The other one is over here, proteins. We break that down into their, their amino acids, and then we take those amino acids, and we basically, again, we can put them into energy production. But we can also cannibalize our own muscle tissue. It's a starvation response. That's why you get thinner when you starve, because the muscles are the first thing it's going to go after, not your fat, which is why getting rid of fat is such a rear-end pain in the gluteus maximus. Anyway, so because it's going to go after these guys first. So basically, again, protein synthesis builds up our muscles. Yeah, I have 0, so yeah. Anyway, again, over here, the triglycerides, again, you can also move that into energy production, but we do lipids synthesis and storage, and when we break down of stored fat, we can turn that into glycerol and fatty acids again for energy production, which is preferably what we want to do when we exercise, is basically make the body break this down, not this. So, yeah. So that's basically why we're eating. And again, they don't show it here either, but there should be a fourth one coming off here for DNA and RNA, because what we do is we break down those base pairs and then take them into our cells and reassemble them into DNA and RNA that we need if we're replicating our cells, or, if we're making a bunch of proteins and we need the RNA. So we do use those as well. I don't know why this picture didn't have the fourth offshoot, which is DNA and RNA. I do not know why. But anyway, so carbs, 3 forms. And this is where I kind of get a little annoyed with people who are usually dieting, because they see carbs as bad. I, as a biologist, see carbs as something you need to live. That's why it drives me nuts when there's those diets that come out and they say, no carbs, no carbs, no carbs. And it's like, dude, if you had no carbs, you'd be dead. So it comes in 3 forms. The monosaccharides, which is the simplest. Mono means one, so it's basically one sugar, which is the honey and the fruits. Disaccharides, which is milk, sugar, and molasses. And then the polysaccharides. This is starch from plants, usually ones it's like amylase we can break down. The other one is, what's the other name for it? There's another, amylase is the enzyme that breaks it down. Amylose is basically bread. Cellulose is, we can't break that down. We don't have 4 stomachs, we're not cows, which I'm fine with. Just saying. I mean, I like cows, they're very nice. Never had a problem with cows. They also taste good. Yeah. So anyway, cellulose is also from plants. We can't digest it, but we need it to clean out the pipes. So occasionally we do need to eat cellulose, just, to give a nice cleaning the pipes out. Yeah. Anyway, so how we use it, we absorb fructose, galactose, and glucose. Glucose is our best buddy. Everything we eat, we basically reduce down to glucose. Glucose is needed for pretty much everything, from making ATP to keeping your brain cells happy. And like I said, out of all the parts of your body, your brain is the hungriest. It eats most of what you eat, which is why when you get hangry, it is because your brain is going, I need to eat. So anyway, and we must listen to our brain. Yes, we must. Anyway, excess glucose is made into glycogen, which is stored in the liver and the muscles, also used in making DNA and RNA, and also used by lactating mothers. I assure you, when I was breastfeeding, I could eat anything. It was, and no weight appeared on my body whatsoever. It is amazing. Amazing. And somebody is calling, which is interesting. So, hold on, let me pause.
A few moments later.
Okay, we're back. Sorry about that. That was somebody was looking for IT and accidentally called me. But hey, misdials happen to us all. Anyway, where was I? So yeah, we're talking about glucose. So again, glucose is made into glycogen, also made DNA and RNA, also used by lactating mothers. So again, we've got the simple carbohydrates and we got the complex carbohydrates, some of which we use, some of which we don't, starches, fibers. But a lot of these we do use, especially our buddy glucose. Now it's funny because all of these are sugars. Remember I said if it ends at ose, it's a sugar? FYI, some of these are not sweet. Like glucose actually isn't sweet, doesn't taste sweet. Fructose, that's why we like fructose. Fructose is sweet. That's usually why we're after that. That's why we eat fruits and things that go, this fruit is tangy and sweet. So, anyway. Just wanted to say, like I said, a lot of people have a misunderstanding of carbohydrates, especially in the diet realm, and that's something that I think needs to be rectified over time, because it's like you should not hate carbs. Do not be angry with the carbs. Should you count calories? Yeah, I do. Not that it always works because I'm a lazy bum. But anyway, just saying, carbs are not your enemy. Now, moderating your carbs, on the other hand, yes. Anyway, so lipids are broken down into fatty acids and glycerol, which is through hydrolysis. So if you remember, we break things apart by actually adding water. It's actually kind of a clever thing we do. So the most common type we eat are triglycerides. So we've got unsaturated and saturated. So unsaturated are no double bonds. These things come from seeds, nuts, plants, oils. They're very healthy. So I keep telling myself every time I get into a jar of peanut butter. Unsaturated, on the other hand, are do have double bonds. That's why they're called saturated. That, and they can, because of the double bonds, they're more compact. So that's why we call them saturated. These unsaturated have no double bonds, and that's why they're not as compact. So these come from meat, eggs, milk, and lard, and too much isn't healthy. So we use this in making ATP, build cell membranes. The liver has the ability to convert fatty acids from one form to the other. However, there are essential fatty acids we cannot make and must get in our diets. So there actually are some types of fats that we need. We also make lipoproteins. So remember those. Also, we use this in making some of those really crazy hormones too. So those lipoproteins are classified on density, which is known as the very low density, the low density, and the high density. And the liver also controls the cholesterol in the bloodstream. Remember, cholesterol is actually used in cell membranes and making hormones. So that cholesterol actually helps, stiffen cell wall, not cell walls, we're not plants, cell membranes, so that way they can maintain a shape, like our neurons. That's why our brain is actually just chock full of cholesterol. So yeah, don't eat brains, they're full of cholesterol. Actually, don't eat brains for many reasons. You can actually get precursors to viruses. They're called prions from eating brains, which we discovered when There's tribes that actually do eat the brains of their deceased to gain their wisdom, and all of a sudden they'd get sick. And it wasn't a virus, it was a prion, which is kind of like a precursor to a virus. So don't eat brains. Don't be a zombie. Don't be a zombie. Anyway, so to maintain those special shapes that make it so we can think and do and all that fun stuff, we have a lot of cholesterol in our brains. So remember, lipids are less dense than proteins. Proteins are the dense. So again, now I get to go on about crazy things. So again, we have the saturated. So again, as you can see, he's got double bond. Wait, I've got this backwards. Yeah, I do. Anyway, difference between unsaturated and saturated. I need to go fix that. Anyway, saturated. No double bonds, as you can see. So also he's straight, so we can condense more of these suckers in. That's why they're saturated. The less double bonds they have, there's no kink, and because of that we can mush more into an area, so that's why it's called saturated. Then you got the unsaturated. So he does have a double, but he's kinked, and because of that we cannot put in too much. So again, healthy, too much unhealthy, and this is insane. So this is the trans fats. So that brings me to the 1950s. Science and chemistry in the 1950s is kind of... We'd just come out of World War II, sitting pretty much, for the most part. All of Europe was a mess, and we were actually paying to get them back on their feet, because without them, who were we going to sell to? America was sitting pretty. We'd just come out as the victors. Everything was great. Troops are returning home. And we had a mentality of we can do anything, especially in science. And that's when we really battened down the hatches and we started up a whole bunch of different things, some of which led to cool things like the space program, which, its origins can be questionable, especially with all those German scientists that we pulled over in Operation Paperclip. But anyway, another thing is we had this mentality of let's do everything, but there was like no real anybody standing there going, but should we? And that's a lot of the problems in 1950s science. There was a lot of yes we can, but not a lot of but should we? And ethics again. So we did a lot of stupid things chemistry wise. We discovered a ton of stuff, but at the same time we just didn't foresee how it would become a problem, because nobody stopped to ask if it would become a problem. We just thought it was awesome, which was one of these things with being trans fats. So there's saturated and unsaturated that live in nature, and our body uses both all the time. However, trans fats is not found in nature anywhere. Even our own body doesn't recognize this stuff. But we decided to use it because it's like, hey, look, we made our own version of fat. It's awesome. Now let's make all this cheese out of it and all this other stuff, and we'll put it in all the food, and we'll put it in because now we don't have to make saturated or unsaturated. We can do it through the power of science and fossil fuels. Yay! And no, our body doesn't know what to do with this. Because of this weird double bond, and it's straight, but it has a double bond, it confuses the snot out of our body. So unfortunately, it sticks it in places that are extremely unhealthy. Like, I don't know, our heart. So that's why, cases of heart disease went whoop. They're, starting at the 1950s when we unleashed this monster into the food ecosystem of America and other countries as well. So that's why, in the 90s you saw this huge rush to get trans fats out of everything, because that's when we finally go, we made this problem. So that's why you saw for this push to get away from trans fats, because our body doesn't know what to do with this, can't break it down, and just stuffs it places, and we get sick as a result. And this isn't the only example. You might be going, oh, well, that's just one example of 1950s silliness. And I'm like, I wouldn't be this way if I didn't have more. Other things we invented back then, one of them was birth control, which is great. But at the same time, we didn't understand that if you've taken any type of chemistry, you'll probably know that, some chemicals come in a left hand or right hand facing, and I just did that backwards, didn't I? This is my right hand. This is my left hand. Wow, I'm good. Anyway, but they come in kind of like our hands, how our hands mirror each other, but, they are, not the same. So there's chemicals like that too. They have a left orientation and a right orientation. And because of this, we used to just produce these chemicals thinking, oh, it's the same chemical, not, even though it has a left and a right orientation. Well, I learned in organic chemistry that, if it has a left, there's a certain chemical that it has a left orientation, same thing, same chemical. If it has the left orientation, it tastes like spearmint. If it has the right orientation, it doesn't taste like spearmint, and it causes cancer. And we didn't realize that. We didn't realize that how it's orientated is a huge deal in chemistry. So when we first made birth control, and we'll get into birth control a little later down the road again. Unfortunately, we made cancerous birth control because we made it with both left and right orientating the chemicals. And unfortunately, left worked as a birth control, right caused ovarian cancer. But it was all mixed up because we didn't know the difference. And so we just put it out on the market without anybody double checking it. So yeah, this is why drugs have to go rigorous testing these days, because we gave a ton of women the first wave that wanted to do, birth control. We basically gave them ovarian cancer, and some of them died from it. So, yeah, this is why we do such heavy drug testing these days before it's ever let out to humans, because we were stupid in 1950s science in a lot of spots. Like I said, there was that weird mentality of we can do no wrong, we just beat up, the bad guys, now we're awesome, and now we're going to do everything, and it's going to be awesome, and just nobody slowed down to say, yeah, but what is this going to do to the body? Or, yeah, what is this going to do to nature? So there's a lot of it. I have so many stories about that. So anyway, so that's the story of trans fats and why trans fats suck. Anyway, so meat. Let's talk about the meat of this. So proteins are the main building block of what makes you you. So remember, enzymes do all the work in your bodies. So, where do they come from? Where does all these amino acids come from? So basically it comes from fish, poultry, dairy products, cereals, legumes, says the woman that eats all the peanut butter. Broken down to an amino acids, we need 20, but there's about 8 we can't make. And so that we have to get them from eating. And there's 10 for growing children. Those are called the essential amino acids, those 8 and or 10 for kids. And where do we get them? So complete, which is fish, meat, dairy, and contains adequate amounts of essential amino acids to maintain tissues, promote natural normal growth and development. And incomplete, which is corn. And I've got a story for you. And one don't I? But anyway, so it contains inadequate essential amino acids, tryptophan, and lysine, therefore do not maintain tissue or promote growth or development. So basically these guys don't have the two things. Remember, this guy right here, if you remember from last chapter, turned on a lot of the enzymes to break down proteins. So we need this guy. They are actually very, very important. Even cats need this. This is why you can't feed cats straight up corn byproducts and stuff like that. I'm sorry, but there are people out there. I mean, there's normal vegetarians who are awesome, wonderful people, and understand that their animals have to have a certain diet. And then there's those weirdos that unfortunately get all the news, which ruins it for everybody else. But they try to feed their cats nothing but straight vegetables. You can't do that. They're obligate carnivores. They have to have it because they need lysine or they'll go blind and die. So yeah. Now, the incomplete actually brings me to an old disease that used to actually hurt the American South. And look it up sometime. It's called pellagra. And did I finally put in? No, I didn't. All right, but I will tell you the story of pellagra. So, once upon a time in the South, um, there was a disease. It was called pellagra, and basically, what would happen is your skin would look horrible. You'd get these horrible rashes. Entire pieces would just slough off. It was bad, and then you die. It was fun, and by fun I mean no, really no. And the South couldn't figure out what was going on. It wasn't happening in the North. It wasn't happening out West. It was happening out West a little bit, but not like crazy much. And nobody could figure it out. And this was a time when diseases, the concept of a virus, was relatively new, and a lot of people were going, "Oh, it must be a virus. Oh, it must be a virus. Oh, it must be a virus." But one doctor from New York City was reading through. He was very interested in pellagra. He was very interested in what was causing it as well. And he too originally thought maybe it's a virus. But then he started noticing the more he read reports of deaths from pellagra, it always came out from two places. It always came out of prisons and orphanages. And he's like, okay, well, if it's a virus, why is it only hitting these two populations? If it's a virus, it should be hitting all populations, not just orphanages and prisons. There's got to be something to this. So he went down south. Him and his wife packed up, went down south, and basically he sat there and said, listen, I want to study what's going on in these orphanages. And he got permission. And he started studying in one state. I can't remember if it was Georgia or Louisiana. He got, kicked out of two states. I think he started in Georgia, but don't quote me. I need to slap in a slide on this with the facts so that way I would get it all straight. And he noticed that the kids were being fed basically, what's a staple of the South? Grits. And what is grits? It's just corn pone, man. And so basically they're being fed grits, and no wonder they were getting pellagra, because corn is incomplete, doesn't have essential amino acids. They weren't getting any meat, fish, or dairy. They weren't getting any, fresh vegetables other than grits. And of course the kids were dying. They were getting pellagra and dying because all they were eating was corn. And that does not make a healthy body. So he noticed this, and he said, dude, you're just feeding them nothing but grits. And they're just like, yeah, man. And he's like, okay. So he decided, he went back to, I think, the governor of Georgia, and he said, listen, I went to all these orphanages, and I found the same thing over and over again. It's grits. They're being fed grits. And they're like, yeah, and, because, it's grits. So he was just like, yeah, that's the problem. They need more than just grits. That's why they're dying. It's not a disease. It's grits. They're just feeding them nothing but grits and nothing else. And that's why they're dying. And he's just like, you're attacking a Southern lifestyle, aren't you? Because you're a damn Yankee. And that's exactly what it was, is they got instantaneously very mad. And he's like, no, let me show you. And he did. He went in. They was given permission again to change the diets of the children, and all of a sudden nobody died of pellagra. He gave them, meat, dairy, fresh fruits and vegetables. But keep in mind, this was, that cost money, and they don't want to hurt their bottom line here. And unfortunately, when they went right back to feeding them nothing but grits to save money, again, the kids would start dying of pellagra. So he posted this. He actually published this over and over again, but none of the doctors in the South want to admit it was their diet. They didn't want to admit that at all. And he was getting so frustrated because the scientists in the South would pull his work apart, going, no, it's a disease. And he goes, it's not a disease. It's basically poor diet. It's poor diet. And finally, he got kicked out of Georgia, and I think he went to Louisiana, which was interesting. And he said, listen, I'm going to set up another experiment, except in, a jail. I'm going to take two groups, and he told this to the governor, and the governor's like, yeah, okay. So he did. He took two groups of, prisoners. He gave one group of 28 a really good diet for, several months, and the other group just ate nothing but grits. And all of a sudden, the group that ate nothing but grits and potatoes got super sick with pellagra. And he's like, there you go. And he published. And again, they screamed at him. They basically tried to run him out on a railroad of Louisiana, I believe, because he pissed off the governor. And again, he sat there and said, listen, it's your food, and I'm not trying to be like a nasty northerner. I'm just saying it's literally your diet. You're feeding these people incomplete. They're not getting all the amino acids they need, and that's why people are getting pellagra and dying. So yeah, it was insane, and it kept going. He even had a party, I'm not kidding you, to show that pellagra didn't come from a virus. He had a party where he and his colleagues and his wife all ate very, very dubious things. They drank saliva from people who had pellagra. They ate skin flakes, because like I said, the one of the signs was the skin would like flake, and like big flakes would fall off. They ate skin flakes. They ate, yeah, I should have put a warning before this, shouldn't I? They ate, warning, it's going to get more disgusting from here. They ate poop pellets. I kid you not. They took poop, they dried it out, they kind of, and turned it into pellets, and they swallowed poop pellets from people who had pellagra. And they sat there and they were fine because they were eating a healthy diet. And they sat there and said, look, we didn't get it because it's not a virus. It's because of diet. And he published this, and he got ripped apart again because he only had one female on the testing team. And it was his wife. That's why he got shot down. So again, he finally had to admit defeat, even though he proved every which way it was freaking diet. He finally went up, and suddenly pellagra left when we started fortifying our cereals. So we started, you see this all the time. If you go into the thing, it says in the corner, it says, there's all the, essential things kids need to grow up. And it's true. We started putting all these things, these amino acids that we desperately need, into cereals. Because people eat cereals all the time here in the United States. Yeah, that's actually how pellagra stopped, was because we forced vitamins into cereal. And pellagra is now a forgotten disease. I bet you didn't know about pellagra, did you? I mean, if you did, cool. But if you didn't, there you go. Nobody knows about pellagra anymore because... And sorry to say, you can't live on grits, which, to some of our grandparents might be something of a shock. Anyway, so if you were with me last semester, or if not, you probably watched this video. It's just Hank going over all of this, and then eating a nasty sandwich at the end. So there, moving on. All right, let's talk about nitrogen balance. This is something we didn't touch on back last semester. So that is this. Remember, catabolism and anabolism of products, which is the breakdown and buildup of products, occurs simultaneously. So we're building down and breaking down. We're building up, and breaking down all the time in our body, all over the place, constantly. So because of this, gain of body proteins equals overall loss, which gives us a dynamic equilibrium. In other words, we're kind of like a balance. And because of these, remember, proteins are basically where we find the most nitrogen in our body. Nitrogen is sorely needed as a major thing that makes up proteins. So breaking it down and building it up leads to nitrogen balance in our body. And that is a condition where nitrogen intake via proteins should equal nitrogen going out. So you'll see this. So again, nitrogen going in our body should equal nitrogen going out of our body. If it's out of whack, that could mean a few things are happening. So if we're using a lot of protein, so we're using a ton of protein, we're eating a lot of protein. So if you're on one of those high protein diets, this is what's going in. And the nitrogen taking in is bigger than the nitrogen going out. This usually occurs during pregnancy because we're literally building a new human being inside of us, or high growth periods. Like my son right now, he's 9, so he's always going through little growth spurts, and then I have to figure out, okay, now what do I put his rear end into? Because he grows up, he hasn't been growing out very much. So they need to make like ultra skinny pants for him. And I don't mean like the skinny pants, like, from days of, what was that? What was the skinny pants rage? I don't know, but not like that. He's a toothpick. Anyway, so if you're growing or you're trying to get all muscly and everything, so you're using you're taking in a lot more nitrogen than putting out. And that's usually because you're building. Now, if the body is undersupported with protein, that means that nitrogen coming in is less than the nitrogen going out, which this occurs during things like fasting, certain diseases, injuries, wounds, because, again, we're using a ton to try and fix ourselves in some form or fashion or fight off a disease. So therefore, it's not, more nitrogen is leaving than coming in, and it leads to a deficit. So that's not cool. And that can lead to major issues as well. So now, energy. And this is where it gets a little confusing, like what is a calorie versus, the science, the chemistry calorie versus the diet calorie, which there is a difference. Okay, so a calorie is the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. Now, kilocalorie is about 1,000 of these calories. Okay, so again, however, a kilocalorie is 1 food calorie. So when you look at the back of a box and it says this has 250 calories, that is equal to 250 kilocalories. Okay, which is, so a food calorie, like you see on the back of the box, is a capital C. A kilocalorie is the chemistry equivalent of that. And the calorie is, basically, lowercase c is basically 1,000, or 1,000 of the lowercase c calories is 1 kilocalorie. See where this gets confusing as all freaking get out? Because nobody decided to get their calories and their kilocalories on the same scale? Ugh. So anyway, so what you see, capital C, calorie, which is the food calorie, is equal to 1 kilocalorie, okay, which is 1,000 lowercase c calories, this is the chemistry side of things, okay? I know, that's just, trust me, I get it. That's why I do an entire lab on this, so you understand the differences between the calories and do the math back and forth, but it's just a pain in the butt. And I apologize for that, because nobody asked me about this insanity. So anyway, so capital C calorie is the food calorie. It's what you see on the back of boxes in the grocery store. The chemistry calories, that equals 1 kilocalorie, which is 1,000 lowercase c calories. Okay? Confused? Yeah. So am I sometimes. Anyway, so fun facts. So about 1 gram of carbohydrates is 4.1 calories. 1 gram of protein is 1.4 calories, which is why, again, I get so mad when people are like, carbohydrates bad. It's like, dude, just moderation, yo. 1 gram of fat, on the other hand, is 9.5 calories. That's the guy you need to worry about. So again, so there's a lot more energy in fat, which is why we store, if we eat too much sugars, we store it in fat. We're just like, we've got too much, we don't need this much ATP, turn it into fat and stick it somewhere. So, and unfortunately, some of us have bodies that, use it more efficiently, and some of us like to stick it away just in case, dinosaurs. So anyway, so there you go. Am I going to test you on this? I need to go back through and double check. I probably will bug you about kilocalories, but I probably won't go, here's a transformation between a kilocalorie and a food calorie, because that will just blow everybody's brain. I think I have like a generic question on calories, but not like, what is a food calorie and what is a chemistry calorie? Because that just, trust me, I get it. Anyway, all right, so speaking of, everybody's different. This is where I want to preface. Everybody's different with this. And that brings us to basal metabolic rate, or BMR. So basically, it's the rate at which your body expends energy under normal basal conditions. When you're awake, at rest, comfortable, etc. When I'm sitting there playing Animal Crossing New Horizons. Because, I've got to keep my little, villagers happy. Anyway, tests of thyroid function can be used to estimate a person's BMR. So it's affected by sex, temperature, size, endocrine activity. Basically, it represents energy necessary to sustain activities of the brain, the heart, the lungs, the kidneys, and the liver. You know, the things keeping you alive. And maintenance requires the body's greatest energy expenditure. So this brings us to a state of energy balance that exists with caloric intake in the form of food equals caloric output resulting in from BMR and muscular activity, which is why a lot of pro athletes go in and get this tested out the wazoo so they can figure that out so they can put out their output just right. You know, I mean, they go in and do the math on a lot of pro athletes, so they've got this. They test their thyroid, they test everything, so that way they can figure out their basal metabolic rate, so that way they know how they can run at peak. Lots of math. Anyway, let's talk about eating. And I mentioned this briefly in the last chapter, but I didn't go in here. So basically, what happens when you get hungry? How does this work? Basically, it's hormones communicating the gastrointestinal tract to the hypothalamus, control the brain, appetite, and monitor fat stores. So again, our friend the hypothalamus is in control. So if the stomach is empty, all of a sudden, it releases ghrelin. And the ghrelin goes and stimulates the hypothalamus. And the hypothalamus goes, hey, I'm hungry. Go eat something. And then what you do is you go and eat something. And then we need to stop the ghrelin from leaving the stomach. So the stomach, the food gets ingested, which stops ghrelin production. But also the food gets ingested and the intestine releases a hormone too. And the pancreas, because he releases insulin. And again, fat intake storage, leptin is released. These four things come together with their powers combined, tell the hypothalamus that you don't need to eat anymore. Yeah, so it takes one hormone to tell the hypothalamus you're hungry, and four to tell it you're not. Wow. So, okay. Now, just in case the hypothalamus doesn't get it, because the ghrelin suddenly stops. Actually, it takes three. These are released. This guy stops, and then three get released to tell it to stop. Crazy. Anyway, so there you go. So our friend ghrelin, he's the one. Now, there are people that where the stomach actually doesn't stop putting out ghrelin and they're hungry all the time. Could you imagine what torture that is? I mean, I'm already pretty close to that because I'm always hungry myself. But not like that. And especially like young children. I mean, there are people that literally have to put locks on their refrigerator and their cabinets and everything where the food is because the kids will get into it because they they're literally under the influence of their own hormone ghrelin telling the hypothalamus it's constantly hungry even though the body is like, we're fine, dude, we don't need that much food, but it's constantly releasing ghrelin. And I feel so sorry for those people that are constantly think they're starving when they're not, and like we need to make a blocker for that. But anyway, because talk about All right, now vitamins. Again, micronutrients include vitamins and minerals, which is essentially aid our cells in metabolism. Remember, we need vitamins to run our, and discussed in chapter 4. I need to switch that. It's chapter 2, actually. And basically, what's happening is the vitamins actually, can control our enzymes. So they serve as coenzymes and minerals as cofactors, which basically regulate how if the enzyme is turned on or off, which controls entire cascades of like reactions in your body. So in addition, vitamins and minerals may themselves be necessary for important body functions like bone growth, nerve impulse transmission, muscle contraction, etc. We talked about this, especially like with calcium for muscle contraction. If we don't have calcium, which, is a vitamin, it's an ion really, but anyway, in this case, same difference. But anyway, so it's a muscle contraction, and lots of fun, insanity. So, if you don't have any calcium, all of a sudden all your muscles stiffen up into one major cramp, and then you can't move, and then your heart can't beat, and then you go. So, yeah, we need vitamins. Vitamins good. So eat your vitamin. Yes, go out and get some Centrum or whatever and eat a vitamin because it's good for you. I do. Anyway, so fat-soluble vitamins. So this is can be stored in the body. So, for instance, vitamin A, basically you get that from anything that's orange, yellow, green vegetables, liver, margarine, egg yolk. Basically, this maintains healthy eyes, skin, bone growth, tooth development, possible aid in cancer protection. Yeah, if you didn't get enough vitamin A, your teeth actually will fall out. Fun. Toxicity, if you get too much. With the fat solubles, that's actually quite possible. You can actually overdose on vitamins, especially the fat solubles, because they dissolve in fat and they're stored in the fat. So they don't exactly leave your body as quickly as the next set of vitamins, which is the water-soluble vitamins. You can actually get a lot of that, and your kidneys just get rid of it for you. And we'll discuss how the kidneys do that when we hit the kidney chapter. But currently, fat-soluble vitamins, you do have to be careful of doing too much. You can do too much because they're fat-soluble, they don't get out of your body fast enough, and it can lead to too much. So you can have signs of toxicity of having too much of any of these 4 vitamins. So signs of deficiency: night blindness, eye infections of skin, respiratory infections. Vitamin D, this comes from milk, eggs, liver, exposure to the sun's ultraviolet rays, which I mentioned earlier. You do have to go outside and get some sunshine. Although I'm one of those people that are like, occasionally I kick myself outside and play in my garden and make sure that all the critters are eating everything that I planted except for me. Because I'm so good at gardening. Not. Alright. Promotes absorption of phosphorus and calcium to build and maintain bones. Loss of appetite. So if you get too much, you got loss of appetite, headache, nausea, weakness, calcification of bone and soft tissue. Rickets. So poor bone development or malformation of teeth. So this actually used to be a major problem, especially with vitamin D. Which is why, again, vitamin D was shoved in, again, fortified cereals. You'll see that, good source of vitamin D. Yeah, it's, again, to prevent not only pellagra, but also rickets, a lot of other things. So, yeah, we actually live in an age where we can actually get a balanced diet, whereas in, years past, decades past, that wasn't always the way to go. It actually took a lot of effort on the government's part to kind of give us more options to eat better. World War I was fascinating because a lot of people get turned down to get put into the army because their teeth were absolutely horrible. I was trying to go for horrendous, but my brain did not work there. So yeah, a lot of people got turned away because their teeth were just bleh, because nobody was taking care of their teeth back then. Ooh. Anyway, moving on. So vitamin E, wheat, germ, whole grains, vegetables, oils, legumes, nuts, dark leafy vegetables, and again protects red blood cells, stabilizes cell membranes. Basically, if you eat too much, you get general digestive discomfort, which I'm not entirely sure. Okay, how is that different from anything else? Rupture of red blood cells, anemia, nerve abnormalities if you don't get enough. So anemia. Vitamin K, which was interesting because we kind of had a rush. I had a glut on this about, I want to say 10 years ago. There was such that rush for kale. So anyway, leafy green vegetables, liver, kale, cabbage, maiden body, intestinal bacteria. Everybody went nuts for kale. Everybody was just like, kale is the new superfood. Eat all the kale. Eat all the kale. Yeah, well, if you get too much, it gives you anemia, and that's not actually a good thing. So too much vitamin K is actually bad. It does assist in normal clotting of blood, but then it can give you anemia if you get too much. And everybody was like, there were people that were overdosing on kale. They were eating way too much kale, and they were getting way too much vitamin K, and that was actually messing them up. Also, kale puts out something that actually kind of acts like another hormone. I want to say estrogen, but I'm not sure if that's it. And it would mess up some people's endocrine system pretty bad too. So there was a big flurry of everything kale. Kale is best. Eat all the kale. And it's like, oh no, slow down. Slow down off the kale. Anyway, slow clotting of blood. So if you don't have enough, you get slow clotting of blood, hemorrhage, especially in newborns. So this is something we've got to be very careful in newborns. But like I said, fat soluble, you've got to be careful because you can overdose on these. Whereas the water soluble, you can, but you need to put in some effort. So these are the water soluble ones. I'm not going to go over crazy much about these. Just pop out a couple things. So B1 thiamine, B2 riboflavin, niacin. Again, niacin's our friend. B6, pathuronic acid, folic acid. He's a big boy. Like I said, if you need iron, you always take it with folic acid because that helps you actually take up the iron. B12, biotin. That's good for our skin and everything. There's a lot of biotin vitamins out there. It's good for your hair and your nails and your skin and stuff like that. Vitamin C. Anyway, these are all water soluble, which means that they can, if you do too much, can be flushed out of your system. You can excess on these, but not like you can excess on those. Like I said, fat soluble don't come out of you very quickly. These, they can come out. Like, there's some people that take vitamin C like crazy, especially when they get sick, but in reality you're just flushing it out with your urine through your kidneys constantly, because what your body needs, it will take. If your body doesn't need it, it will get rid of it through your kidneys. And we'll talk more about that later. So anyway, so like I said, interesting stuff. So, but if you didn't get enough, you got scurvy. Oh no, you'd lose teeth that way too. Scurvy, and then you'd be a pirate, and then, no wait. That's why, pirates used to bring a lot of fruits and everything that were high in vitamin C with them, because they finally figured out, yeah, we need more vitamin C, so that way we aren't, dying of scurvy while we're pirating. Yar. Anyway. Minerals, again, all of these guys are the big boys right here, because like I said, calcium, phosphorus, sulfur, potassium. Gee, aren't some of these kind of familiar from what I was talking about, the muscle system and the nervous system? Chlorine, sodium, magnesium, iron. Again, he works best with folic acid, so if you need to take iron supplements for any reason, always take it with a folic acid. Always consult your doctor first, because I am not a doctor. I only I only stayed in a Holiday Inn last night. Actually, I didn't. Fluorine, zinc, copper, manganese, iodine, cobalt, selenium. Interesting. We get that from seafood. Chromium, and molybdenum. Isn't that fun to say? Molybdenum. Molybdenum. Anyway, so, yeah. There you go. You can go over this at your leisure. This guy is a hoot and a half. He is a principal. I don't know if you've ever seen this guy. He is a principal in, I'll put this up with the thing, but he is a principal with an elementary school, and he does the funniest stuff. He's a hoot and a half. Now Jerry Brooks, I believe. Jerry Brooks? Yeah. He's a hoot and a half. Check him out sometime. I'll put this up as a funny. I'll just put parentheses funny, so that way you can watch it. It's because it's just silly. It's him going over the foods you should eat. He's a goofball. Alright, so starvation. Since we've been talking about eating, let's talk about not eating, which is something I can't do. I like eating, anyway, as you can see. Anyway, so a person can survive about 60 to 70 days without food. Without water, you can survive less than a week. Sorry, you need water more than you need food. However, but the body starts digesting itself, which is an interesting story in itself. There was actually, during World War II, there was a siege. I want to say Leningrad, but there was a siege of a Russian city. And in that Russian city was basically the warehouse where they stored all of the seeds that the farmers in Russia use. And this was all the grain that would produce the food for all of Russia. And there was scientists protecting it. So they had a huge warehouse filled with food. But the scientists protecting the grain starved to death because they were going to protect that grain with their lives, because they knew if they even touched so much as any little piece, Russia wouldn't, for the springtime, Russia wouldn't have anything to plant, and there would be countrywide famine. So these people protected that warehouse with their lives while they starved to death. And they even journaled the whole ordeal, including how they felt in the different stages of starvation. And it was pretty insane. So yeah, look it up sometime. I want to say it was the siege of Leningrad, but I'm not for surezies on that. No, let me just go double check real quick. Let's see. Russian starvation. No, not an experiment. Yeah, that's not cool. Russian starvation experiment that popped up? That's not cool. That's what I was talking about. Protect brain. Soviet famine. No? I'll look it up and try to find a. Yeah, that's not it. Tragedy of the first seedling? I don't know. I'll look it up later. I'm not entirely sure where the heck it is. Anyway, I'll post it later. Alright, so, or if you can find it, post it in the forums. Anyway, so Marsimus and Kwashiorkor. So basically, this is Marsimus is the due to lack of all nutrients. Kwashiorkor is due to a protein deficiency. Test questions. Test questions. Anorexia nervosa. This is self-starvation, and bulimia, characterized by binging and purging, which is basically what's going on there. So anorexia nervosa. Yeah, and unfortunately, these are also quite mental disorders, which are not good. There was a former, I don't think she was bulimic, I think she was anorexia nervosa. But anyway, she was a former model, famous model, and she put up her body, or what was left of it, because of that, as posters going, don't do this to yourself, please go get help. Because she had gotten to a point where there was nothing much that she could do. It was just so bad. But so she decided to turn herself into a don't be like me, and literally had people, take pictures of how bad her body is before she died, and, spread that all over in a campaign to bring awareness to both anorexia nervosa and bulimia. So, it's rough, especially rough to fight against. Once you kind of go down that rabbit hole, it's really hard to stop yourself from going down that rabbit hole, because like I said, it's not just physical, it's a lot mental too. And so, anybody, fighting your brain is so very hard to do. So hard to do. So age and metabolism. So again, I split this up into 3 parts. So nutritional energy requirements change with age, also depend on medical conditions, social, economic conditions, because, depending on what's going on, you may not have the money to get, or what you need to get to eat a proper diet, or the time, A lot of us, and I'm sure you guys know, because a lot of you, posted how much you're doing on top of all of this. It's hard to eat a balanced diet when you're always trying to, do shifts work and stuff like that. It's rough. So nobody's got, usually people at home cooking for you a nice balanced meal. So anyway, BMR, so basically it rises in early childhood, declines in middle to late childhood, peaks again in adolescence when you kind of finish off turning into an adult, and then declines with age thereafter. Any age, basically weight gain occurs. This is just, they make it sound so simple, which is true. This is true, but at the same time, it's like, okay, easier said than done, weight gain occurs when energy in exceeds energy out, and weight loss occurs when energy out exceeds energy in. It's like I said, completely true, but at the same time, for those of us looking to lose weight, or some people gain weight, it's easier said than done. But anyway, with that said, we have just now covered the entirety of Chapter 18 in one go, or I like to call it Chapter 2, Round 2. So, with that said, I'll see you next week. Take it easy, and bye!